Welcome back. So as promised, I'm going to explain to you how these problems are solved all the way. So we agreed that these two triangles, I'm sure you already sketched them too. I just want to reinforce. So I'm going to start this one fresh, okay? You're given side 22, B22, and angle 42, right? So we already established that this is an as, right? And I think we already sketched it, and it looked like this. All right, and draw it exactly the way it should look. Try to get this is called a good sketch. Okay, a good sketch indicates 42 degrees as it should be. 12, 22, it looks almost doubled, okay? So it looks like we can, based on this good sketch, it could be one triangle. You could check if you must, so I checked it for you. But we already know that this side, if it's longer than this guy here, right, compared to this height here, right? It's obviously longer than this, but we must be sure that it's longer than this side here. And we know that it's actually one triangle. So one triangle is our conclusion. So we're going to solve for that one triangle. So I showed all my work. If you want, you can actually go ahead and try to screenshot this and try to understand the work, okay? Now solve for the triangle. So I'm going to solve for this triangle, okay? I'd set it up. Sine 42 over 22 equals sine B over 12 equals sine C of angle C. Divided by C, side C, okay? So these are the things that we don't know, but we already know sine angle, so that means I'm going to solve this guy first, right? So sine of angle B is equal to 12 sine 42 divided by 22, because cross multiply. So I know that I need the inverse, so I did inverse of sine, 12 sine 42, 22. I entered it into the calculator just like this, which is B, and which gives you 21.406. For this purpose only, I made the angles to thousands. So we're just rounding always to the thousands. But I know that in the class, I said round angles to the nearest tenths, okay? All right, let's go. Now you know angle A, you know B. So the second step, naturally, after when you're solving, should be to solve for angle C, the third angle. So what I did is this, 180 minus angle A plus angle B. But angle B, you probably want to just drag that into here. So store it or enter into the calculator with this answer here. So I did 180 minus parentheses angle A plus angle B. And that gives you angle C, which I got 116.594. So we know this angle, and this angle. So I guess we need C. So we're going to go back to this law signs, right? So now we can use this. But I like to use this guy and this guy. So that's how I set it up. Because this was given to me, I solved this. So what if you solve this wrong, right? So it's probably better to use what's given. So what I did is I set it up as sine 42 is equal to sine of angle C, which we calculated, over C because we need that. Okay? And again, it's C equals 22 sine 116.594 divided by sine 42, which I got is 29.4 for length C. So now I have actually concluded by doing this. Angle ABC. Now this should be 180 when you add it together. And that's why we say to round to the nearest tenths, because there's oftentimes it might go a little over 180 or a little under 180 if you round to the nearest thousands, okay? And the sides are here. Make sure from the largest angle, it's the biggest side. And shortest angle, smallest side. Okay? So make sure your angles make sense, okay? Now let's move on to your other one, okay? So this question here, again, this is an as case because you know it's C and C as case, right? It's an as case, which means two triangles, right? Well, we'll check to see that's triangles. I think in class we already established that this is two triangles. So we're gonna sketch this sucker, okay? I'm gonna sketch this. So I'm gonna put C at the bottom here, C 15 here. Okay, 15. Oh, I'm so sorry. I don't want to put C there. Okay, I'm going to draw a base. I'm going to draw a base here. I don't know what that guy is yet, but I know that this angle is C. So I'm going to put C here. Okay, and I'm going to draw this guy as A, right? Because this guy, so that means this guy is A. Okay, so this guy is A. It's about 20. So if that's A, that's little a, and that's 20, right? C is 15, so maybe about 3/4 of the way. So maybe like about here. Okay, and 15. And that equals little c. But now we're like, okay, I could swing this around, right? And maybe I could make two triangles, or I could make one triangle or 0. So if you want, go ahead and, I did it in class, right? You can compare it to the height. We know for sure that this guy is shorter than this. But we've got to make sure that it's longer than the height. Remember what we talked about in class? when I showed it with the string, remember? So maybe this is going to go around and make 2 triangles or 1 triangle. We don't know because this length here at the base, it's adjustable. Okay, so let's try this, okay? So this is the first step, sketch, and we established that it's as, okay? Now based on the set, it's a little hard to tell, right? Hard to tell. So what I'm going to do is I'm going to calculate the height. And height is 20 sine 22 degrees because this guy is given that it's 22. Okay, so we're doing sine of 22 is h over 20, and that's that. So I get the height is 7.492. Wait a minute, so that means our h is less than our 15, which is our given, and it's also less than a. It's greater than the height, but less than a. Remember that? That means it's going to be 2 triangles, and that's why this one's a little bit trickier. And what are the triangles? So what I'm going to do, you guys, is I'm going to, because that means it's going to be a triangle here. Look at this, okay? And there's going to be a triangle here. So this guy, when it comes around, it's going to go here and then here, okay? So it should work out that way, okay? Okay, so I'm going to erase this part here now so you can see it better, okay? So it looks like this guy is 15 equals C, and this could be the other one, 15 equals C, this guy here. But you guys, sometimes it's really hard to see, so I'm going to draw the 2 triangles. If it's 2 triangles, I would always suggest that you draw it out. So I'm going to use that to guide me. I'm going to draw my obtuse, so it goes like that, right? Oops. I'm going to always draw them out separately, but the way they should look. This is 22, this is C, this is A equals 20, always, and this is C equals 15, right? That means this guy is what? This guy has to be A, right? But you see how there's an A here and an A here? So we're going to call this guy A1, this guy A2. Not to be confused, okay? And look, isn't this guy B then? Because that's the only missing angle. So then you see you have a B here, and you have a B here, right? So I'm going to call this guy B1 and B2. Okay? Try to digest that, okay? Now let's make it here. That means I have B1 here, and this guy is A1 here. Okay? Okay. I'm going to draw the other triangle. See, this is the first triangle, and this is the other triangle here. You see this other triangle? So I'm going to draw that triangle too. I'm going to draw it kind of similar, as same as possible. But I don't know if I mentioned this, but you guys, isn't this 15? And isn't this 15? Oh, so they're isosceles triangles. So that means this guy here, it's the same thing as this guy, because base angles of isosceles triangles are congruent. That means if I know this angle here, which is A sub 1, I'll know this guy because they're supplementary. In essence, that I know A2 of the other triangle. So you see how they're all related. So let's go back here. We know that this guy is C equals 15, right? And this guy is A equals 20. And this guy is my C. That stays exactly the way it is. Except this guy is now A2. This guy is B2. Makes sense? Make sure you compare it with the other triangle that you see above. But watch. What's different? Oh, sorry about that, you guys. The little guy here, this guy is little b1. So that's that guy right here. And then the big one here, this is big base 2. So we have to solve for all this. Okay? Let's go on with it. Okay? So now, I have to give you guys a little hint. Always try to solve for, if there's an obtuse and an acute triangle, always try to find the obtuse angle first. It's going to be helpful to you, okay? Always try to find the obtuse first. And I'm sorry, not the obtuse, the acute first. Acute first, okay? So try to find the acute first. So you know what we're going to do? We're going to go to this triangle first. So let's solve this triangle first, okay? So we're going to set it up, okay? We're going to go, let's just set up the actual law of sines, okay? So we're going to go sine of 22 degrees over 15, right? Is equal to sine of A2, which is equal to over 20. And then sine of B2, which is over B2. Always find the acute triangle first. Trust me on this, okay? Now we can actually solve for A2 here, right? So let's do that first. Okay, so I'm going to actually find A2 first. So I'm going to go A2. Oh, I think the solving is the easier part. Sine of A2 is equal to 20 sine 22, right? All over 15. You agree with me? Okay. So 20, A2 is 20 sine 22 divided by 15. So that means it's inverse sine of 20 sine 22 degrees over. Okay, so when I set this up as sine to find angle sine A2, then I get 20 sine 22 divided by 15. As you can see how this equation works out. And now I can set it up, and when I calculate this using the inverse sine, I get that A2 is 30. So let's label that here, okay? A2 is 30 degrees here. If that's about A2 is about 30 degrees, then you know that these are related, right? This side and this side. Because as we go back here, we know that these are supplementary, right? Okay, that means we should find, logically, we should find A1 now. So A1 is simply equal to 180 minus 30 degrees, which is A sub 2. Because they're supplementary angles, right? All right, so then we get 150. So let's label that too. Oh my gosh, so we know now almost all the angles for everything, right? So now we can say B1 is what? B1 is going to be 150, 22, so it's going to be 172, so it's going to be 8 degrees about, right? Okay, so we know B1. So then from there, we know B1 is 8 degrees, so we should write that down. Okay, we also know if this guy is 22 and this guy is 30, we know this guy has to be 128 degrees. We should write that too. So we know all the angles almost, right? So B2 is also equal to B2 is equal to 128 degrees. So we know this, we know almost everything. So once we found all that, what are we missing? We have to find B2. The only thing we're missing is B1 and B2. So we'll go back to your equation. Think about B1 and B2. Okay, so let's find B2 first. How about that? Okay, so let's go to, let's do the third step. Because you see how all these things came naturally? So let's go to sine 22, our original equation for 15. We're going to finish solving this guy first. Is equal to sine of B2, right? B2, which is right here. B2, which is right there. So I like to try to use the actual integrity of the 128, whatever it was, okay? So try to using the real values, okay? So I'm going to put 128 here, but try to use the real values over B1, right? Little B2, I'm sorry. So then when I solve this, I get B2 is equal to, B2 is equal to, so you guys cross multiply. So I would get 15 sine 128 divided by sine of 22, right? Okay? So I got B2 is equal to about 31.539. Can you guys make sure you guys get the same kind of answer? Okay. Now we found B2. So we know that this sucker here is 31.539. Okay. All right. So we're almost done. Now we just need B1. So let's set it up. B1, right? We need to find B1. So let's go back here. Let's see what we know. We know that sine of 22 over 15, which were the given, is going to equal, we need B, right? So sine of B1, which was about 8 degrees, right? We calculated that 8 degrees, all over B1, whatever that guy is. So therefore, B1 is equal to, 15 sine 8 degrees all over sine 22 degrees, right? Then you get B1, when you calculate that, did you guys get something like 5.549? Okay, and that would be B1. Okay, so let's write that, okay? So B1 is going to equal 5.549. But you guys, it's really helpful if you draw the two triangles out. That's the number one thing. And you're right, there's a lot of work involved, okay? It's going to come more naturally to you, but let's summarize it, okay? So how I want it is this, okay? You have your A1, B1, C1 for your first triangle, and you have your little A1, little B1, little C1, okay? And you also have your A2, B2, C2 for all your angles, and you also have your A2, B2, and C2 for all your sides. So if I was to ask for the answers, I would want it all laid out this way. So let's look at the first triangle here. You see your big A1, it's going to be 150 degrees. C1 is easy because it's 22 degrees, and that's given, so I'm going to box that. B1, you calculate it, it's 8 degrees. Little a1, which was it given? If it was a1 given, then just write 20 and let's box it because a was given. Okay, little b1 you calculated, so I got that. Okay, and little c1, it was c1 15, which was given. So 3 pieces of information, a side, right? Oh, sorry, angle side. Okay, let's go to your other triangle. Let's calculate. You're looking at your data, right? So look, I'm gonna actually move this a little bit. I'm gonna go like that, so you can look at your data with me. Okay. So A2, what's A2? Look at. Sorry, you can't see it. A2. You know A2 is 30 degrees. Okay, you calculated that yourself. B2 is this guy here. You calculated that yourself too. Oh no, B2. Wait, did we calculate that? We did. Okay. We calculated that. Okay, and we calculated that. Okay. Let's go to C2, that's already given to us, right? And make sure this adds up to 180, okay? And A2, we know it's going to be 20, and that was given to us. And C1, that's given to us. C2, it's given to us too, right? For the second triangle, right? And B2, we calculated, we got 31.539. Okay, hope this helps. We'll practice more in class. See you!